morning, people. I hope you're doing well, my lovelies, because we've got some science that may contain science. Science that rocks, and in more ways than one. But seriously, yes, this is about a rock, and a rock we've talked about before. Bennu, the asteroid that was the subject of a previous episode of May Contain Science, and the target of the OSIRIS-REx mission. In late September of this past year, OSIRIS basically airdropped 250 grams of Bennu at our door, then bounced off to retirement out in space. 250 grams isn't, like, a lot, but it's 50 times more than we've ever gotten out of an asteroid sample collection before. In part because the sampling kept going wrong on previous asteroid sampling missions. And it turns out the OSIRIS-REx mission went kind of pear-shaped too, but at least we got results. And as the recently published initial analysis indicates, Bennu was everything we hoped for, and more. In fact, everything we hoped for and more describes the Bennu sample in more ways than one. We mentioned before that Bennu sample collection exceeded mission expectations by 500%. Well, it apparently gathered so much material that particles escaped containment. Okay, not totally. They were still inside the outer containment, but it seems that a rock, just a little over an inch in size, 3.5 centimeters, if you're not freedom unit inclined, got stuck in the sample collector, prying open a flap like a door jamb and letting some of the sample material leak out. Oh no, that's bad, you might say. And for a mission 20 years in the making and painstakingly planned, yeah, that's usually true. But in this case, it is weirdly kinda good. And that's because this equipment gone wrong problem saves us from a different equipment gone wrong problem. The material that leaked into the outer lid is the primary source of Bennu material we can sample right now because, we still can't get into the sample container. Yeah, sorry. We still can't get into the sample container. It's kinda... how do I put this? It's stuck. There are 35 fasteners on the TAGSAM, or Touch and Go Sample Acquisition Mechanism collector. 33 of them worked exactly like they were supposed to. 2 of them, yeah, not so much, and we cannot get them unstuck. Now, normally, we'd just hand it off to someone who'd unstick them real quick, like a particularly stubborn jar of marinara, and say something humble like, "Oh, you loosened it for me, I just finished the job." But it's really, really important that we do this unfastening properly, because Queen guitarist Brian May worked too hard to help scientists get this sample, and we're not going to ruin things for him now. Yeah, I should probably say, I'm actually not joking about that. I didn't mention it in our first story, but a key collaborator on the OSIRIS-REx mission was Brian May. I.e., I'm sure plenty of people knew this as a piece of trivia, but I sure didn't. PhD astrophysicist Brian May, who dropped his in-progress doctoral studies back in the 70s to, form one of the biggest rock bands in history or whatever. He actually went back and finished his degree in 2007 and has been actively using it ever since. Dr. May, professor of rock, has collaborated on several space missions, contributing imaging and analysis to previous asteroid sample collection missions and other asteroid-related missions we've covered before on May Contain Science, including NASA's, well, let's slam into an asteroid and try to bump it off course, DART mission. This knowledge has, yes, wholly recontextualized We Will Rock You for me, and dude absolutely deserves his position as only person on Earth who's been awarded both a spot in the Rock and Roll Hall of Fame and the Lawrence J. Burpee Medal of the Royal Canadian Geographical Society for outstanding contributions to the advancement of geography. But even though we had a famous musician find the perfect parking spot for our lander, the sample collection didn't go smoothly, and now here we are, trying to access the precious space rock out of the stuck sample container that we can only even access because a rock jammed a little flap of the container open, and now we're scraping the lid of the container for the material that spilled out and literally picking pieces out of the container through that open flap with tweezers while NASA fabricates new screwdrivers to unstick the stuck fasteners and open the container without contaminating the sample with our Earth nonsense. And that's where finally, the OSIRIS-REx mission got lucky, in that sort of luck is where preparation meets opportunity sort of way. In our last story, we focused on the contamination protocols on the OSIRIS-REx mission and how important they are to proving that organic molecules in the Bennu sample are actually from Bennu. The OSIRIS-REx contamination protocol emphasized that you can't fully scrub everything, and what would that even mean? But they specifically focused on decontaminating the actual sampling equipment itself and everything that came in contact with it. That includes the outer lid of the sample, which means 1, the sample is still good despite the leak, and 2, while we wait to unstick the scientific marinara jar, we can study the stuff that fell out onto the lid because we made sure to ultra decontaminate that equipment. Let's go! And oh my gosh, y'all, what we found is so cool that it makes this whole mess worth it. Bennu was chosen, among other reasons, because preliminary analysis indicated that the rock was high in both water and organic molecules. Organic molecules to chemists being any chemical compound that contains carbon to carbon or carbon to hydrogen bonds. The initial analyses, performed within a few weeks of sample drop-off, proved that Bennu is indeed high in both these things, and that alone came as a payoff to those 20 years of mission planning. We got what we came for, and in a big way. From there, material was sent off to the Reflectance Experiment Laboratory in Rhode Island and to the Natural History Museum in London, both receiving just a little bit sent super carefully. This, for instance, is the sample sent to London, which itself is, quote, unbelievably exciting to Professor of Cosmic Mineralogy and Planetary Science Sarah Russell, and thus began the more detailed analyses of what exactly is in Bennu. Some compounds one could reasonably expect in such an asteroid, particularly with what we know of it now. We found phyllosilicates, which are made from silicon and oxygen. Examples include talc and mica. We found sulfide minerals. We found magnetite, which is an iron oxide that's easily magnetized. We also confirmed suspected inorganic carbonates, which are compounds we sometimes use as a clue that a space rock has water. Though, at this point, we know Bennu has water because we finally get to get nice up close and personal with it. On the organic side, we found polycyclic aromatic hydrocarbons, which are pretty-looking rings of hydrocarbons that are surprisingly prevalent out there in interstellar medium and are a good starting Pokemon for more complex organic compounds like amino acids and nucleotides. In fact, Ryugu, the asteroid sampled by previous mission Hayabusa 2, has a whole ton of complex organic compounds, including straight-up the nucleobase uracil, so it's possible, if not probable, that the compounds we, the public, are learning about are just the beginning of what we will have brought from Bennu. More specifics on the organic compounds will be forthcoming in late spring, so I can't confirm we found any particular polycyclic aromatic hydrocarbons like this hexabenzochroinine I'm showing. I can only confirm that hexabenzochroinine is pretty. And hopefully, by late spring, they'll have figured out some of the apparently weird aspects of Bennu's composition. In fact, Principal investigator Dante Loretta reported a lot of these findings at a recent meeting of the American Geophysical Union, where he admitted to fellow rock nerds that the cosmic chemistry of Bennu is unlike anything he's ever seen, and he's seen a lot of space rocks. Bennu's got a lot of magnesium, sodium, and phosphorus, all of which you do see in space rocks, but the combination and proportions are what's unusual here, enough that Loretta called it a, quote, head-scratcher. Even though it caused some problems, it's a good thing the OSIRIS-REx mission gave us a lot of material, because according to Loretta, cosmic chemists are about to go to town on all that Bennu has to offer. And while those chemists tap their feet impatiently, good luck to NASA, who's still synthesizing screwdrivers to crack open the rest of that sample. I'm sure the researchers have loosened the container for you.